Homework 1. If you need a temperature and it's not given in the problem, we're going to assume 298 K. So just keep that in mind as we're working problems. Now the first question says choose one to define, and then we're given 3 choices. Now on the quiz you're going to be told what you will be defining, but for the homework I wanted to make sure that you had a choice. So if you choose the intermolecular forces that make up solutions, what I want you to do is I want you to take a look at the solute-solute interactions, the solute-solvent, and the solvent-solvent interactions, and I want you to describe to me what happens when a solute is dissolved into a solvent. You can touch on the ion-dipole interactions if you so choose, but I'm really interested in the solute-to-solvent interactions. If you choose electrolytes, not only do I expect you to define what an electrolyte is, but I expect you to work into the definition, what are weak and strong electrolytes. Have some example forces one. A drawing might be a good idea too. Now, if you choose saturated, unsaturated, and supersaturated solutions, I would expect you to tell me about the maximum amount of solute that a solvent can hold at that temperature, and then you decrease the temperature of the solution and it becomes supersaturated until it starts falling out of solution. I expect you to work me through what these things mean. I also hope to see an example. Now for your homework, I'm likely to give you all of the credit if you give it a try, but for the quiz, I will be grading it rather stringently. So make sure it's college level answers there. Number 2, calculate the molarity of a solution that is comprised of 150 grams of glucose, and you're given the chemical formula, made to a volume of 250 milliliters. Well, in order to calculate molarity, you need to remember that we need the moles of the solute, and we're going to divide that by the liters of the solution. So to calculate the moles of the solute, I start with my 150 grams of glucose. I'm going to leave the chemical formula off for now, but go to the periodic table, which is at the bottom of this homework assignment here. And I'm going to work on making that a little bit larger because I think those numbers are hard to read, at least with my older eyes they are. But you may need to have a periodic table as well. So keep that in mind. So when we go to the periodic table, carbon is 12.01, hydrogen is 1.01, oxygen is 16, and the chemical formula, just to recap, is C6H12O6. So when we add all that together, so 1 mole of glucose has a mass of 180.15, I think that's a 6. I'm having a difficult time reading my writing, but grams of glucose. So we convert that into moles. We get 0.8307. I'm going to leave that in my calculator. I leave that in my calculator because I don't want to introduce rounding error. So now we're told that we had a volume of 250 milliliters. So I'm going to convert that into liters. So I start with my moles. Again, this is in my calculator. And I'm going to divide that by 250 but converted into liters. Remember, 250 was here. We moved the decimal place 3 times in order to convert that into liters. So that will generate the molarity. So the molarity of this solution I calculate to be 3.323 capital M molar. Go back, double check my sig figs. I have 4 sig figs in each place. So I would enter 3.323. Do not enter the M, just the number, unless you are otherwise told. Number 3, a solution of caffeine, and here's the chemical formula, is created with 47.8 grams to make a volume of 275 milliliters. What's the percent mass? Now, just for clarity's sake, you should be able to calculate molarity, molality, and percent mass. And you could be asked to do that for all of the same conditions. Just keep that in mind as well. So if we have our caffeine solution is what we're working on. So caffeine is C8H10N4O2, and that has well, we don't need its formula mass. So in order to find the mass percent, I need the mass of the solute, and I'll divide that by the mass of the solution. Remember, the solution is comprised of the solute and the solvent, and I'll multiply that by 100 to get my percent. So the mass of the solute was given. It was 47.8 grams. The mass of the solution I need to calculate. So I have the mass of my solute, but the mass of my solvent, I was told 275 milliliters. I was told to consider the density of water to be defined as 1 gram per milliliter. So I can take that 275 milliliters and call that 275 grams. Perform that arithmetic and I get 14.8%. Come back over here, double check my significant figures. I have 3 sig figs in each of those places. We're told that this 1.0 is defined, so we ignore that for significant figures and just punch in your 14.8. Leave the percent off. Number 4, what are the mole fractions of phosphoric acid and water in a solution that is 20 grams phosphoric acid in 25 grams of water? Now, I want to be clear with this formatting here. It says show your work. Only typing the answer without the work will only earn 1 point. You may submit your handwritten work to me after your quiz is through. For your homework, I want you to type it all out. You can also use the insert an image and you can embed the image there. That's okay for the homework. For the quiz, you're not going to have that functionality because the quiz is going to be respondus gated. So you can put your answer here and then upload your work after you submit your quiz. And I'll show you how that works with the quiz header video. But for the homework, this is how we solve this problem. So we're going to start with the mole fraction of our acid. And then we'll move into the mole fraction of our water. So we need to know how many moles of our acid we have. We're told we have 20.0 grams of H3PO4, and we have 25.0 grams of water. So first, let's convert these into moles. So my 20 grams of H3PO4, I'm going to use the molar mass. And I find that molar mass by looking at the atomic masses on the periodic table. And I calculate 97.994 grams of phosphoric acid per mole. So I get 0.20409 moles of phosphoric acid. Now for my water, the molar mass of water, hydrogen is 1.01, oxygen is 16. So this is 18.02 grams of water per mole of water. And I get 1.3873 moles of water. Now I have too many significant digits on purpose. I want to make sure I'm not introducing additional rounding error. So to find the mole fraction of my phosphoric acid, I need to take the moles of the acid, the moles of the solute, and divide it by the total number of moles. So I use my 0.20409 moles here, and I divide that by the sum of the moles that I've found. And I get a mole fraction of 0.128. Now that's the mole fraction of my phosphoric acid. Now you could do this 2 ways. You could say 1 minus this business is going to be the mole fraction of water. Or you could calculate the mole fraction of water by taking the number of moles of water and dividing it by the sum of the 2 molar values that you have obtained. And you should get 0.872. Now, to enter into the homework, what I would expect to see is the mole fraction of H3PO4 is equal to, what did I have? 0.128. And the mole fraction of water is equal to 872. Now, use the editor here and take this, well, I put a 2. Take the acid and drop it into the subscript. Use the editor to your advantage. Be clear about what it is you're reporting. If you just report this and never send me your work, you're only going to get 1 point. If you send me your work after the fact, your handwritten work, that's okay, and I'll show you how to do that. If you want to type in all of your work, I suggest you type in your work after you have answered all of the questions. So let's move on to number 5. What is the boiling point, freezing point, and osmotic pressure of a solution that has a volume of 250 milliliters that contains 22.7 grams of methanol in water? Now it's in water that means the most here. So in water means we're using this row of data. So what we'll do first is calculate how many moles we're working with. So we have 22.7 grams of methanol. The chemical formula of methanol was given to you, CH3OH. We're going to calculate the molar mass. So 1 mole of methanol has a mass of 32.04 grams of methanol. And so I have 0.708489, and that's moles of methanol. I'm leaving that in my calculator in order not to introduce any rounding error. Now you do need to calculate molality. You need molality for the boiling point and the freezing point. So molality is moles of solute divided by kilograms of solvent. So now I have my moles of solute, the kilograms of solvent. Again, we're going to assume that water, unless you're told otherwise, water will be defined as being 1 gram per milliliter. So because we have 250 milliliters, we have 0.205 kilograms of our solvent. Now this mole value is going to go here for the moles of my solute. And that leads to a molality value of 2.833. I'm going to give you way too many digits. 957 little m molality. Now for the boiling point depression, the change in temperature is going to be equal to the mass times the appropriate C value. Or the molality, not the mass. So the molality given here, 2.833957 or whatever's in the calculator, times, and now I need that data from the table, 0.512 Celsius per molal unit, and I get 1.45098 blah, blah, blah. That's boiling point. So because it's boiling point, the boiling point of water is 100 degrees Celsius, so I'm adding this to 100. So my new boiling point, 45 something or other, and because it's given to me as 100.0, I would round this to 101.5. So going over here, I would say boiling point, or maybe new boiling point, is 101.5 degrees Celsius. Select it, superscript it. So now I'm going to calculate the new freezing point. So for the freezing point, it's a similar calculation. It's what we do at the end that's different. The 2.833957 stuff. But now we need the freezing point K, 1.86. So the change in temperature for this is going to be, I get a 5.27. They were 0, so I'm going to subtract this from 0, 0 minus 5.27, and I think it's listed as 0.0. So we're going to round that as 5.3 degrees Celsius. And that's a negative. Make sure to keep the sign. The sign is important. So now the osmotic pressure. For the osmotic pressure, we need the molarity. Molarity is different than molality. So for the osmotic pressure, we need a capital M, molarity, times R times T. Now the molarity is the moles that we calculated above. So here we go, 0.708, that one. And we're going to divide that by the volume of the solution in liters. So it's 0.250 liters. This is moles. And here the molarity value happens to be equivalent to the molality value. That's not always the case, but every now and then. So now we're going to plug that number in for the capital M molarity. My R value, that is my universal gas constant, 0.08206, that's liters, atmospheres, mole, Kelvin, times the temperature, 298 Kelvin. Remember, if you weren't given a temperature, you were told to assume 298. So when I multiply all of this together, I get a value of 69.3 units for that is atmospheres. So I would come over here, and if I don't know how to make a pi symbol, just put osmotic pressure equals 69.3 ATM atmospheres. Go on, answer the rest of your questions before you come back to show your work. Number 6, what is the molar mass of a solution of 5 grams of a compound in 25 grams of carbon tetrachloride? You're given the boiling point, the Kb, and the new boiling point that contains this amount of substance. The first thing we'll do is we will calculate the change in temperature. So we were given a new boiling point with something in it at 78.6. The original boiling point was 76.8. So that gives me a delta T of 1.8 degrees Celsius. Now that delta T value is going to be equal to the molality times the Kb. The Kb was given to us, and that was 5.02 degrees Celsius per molal unit. So now we plug in what we have and we solve for what we know, what we don't know. We don't know molal unit, so we divide both sides by 5.02, and I get an M is equal to 0.35. I'm going to give you too many digits here, 657. Now that is moles of solute over kilograms of solvent. Now we were told, go back to the problem here, 25.0 grams of carbon tetrachloride is my solvent. So because I'm told that I have 25 grams, I'm going to set this up here like this. So this is moles of solute per kilogram of solvent. So that is equal to some number of moles of solute over 0.0250 kilograms of solvent. So when I solve for this, then what I get is my moles of solute are equal to 8.964 times 10 to the negative 3 moles. Now I have a mass, and I'm looking for molar mass. Molar mass is grams per mole. I was told that my sample had 5.00 grams. I've calculated that I have 8.964 times 10 to the negative 3 moles in this sample. So that means my molar mass, if I take 5 and divide it by 8.964 times 10 to the negative 3, I get 557.78 grams per mole. Go back and check significant figures. I see 3 significant figures everywhere. So I would call this 558 grams per mole. So after you have answered all of the questions in the quiz, you can then go back and fill in the work.